हे एवरीवन, काफ़ी लोगों का मैसेजेस आ रहे हैं कि क्वेश्चंस हार्ड थे। शुभम, आज अनफॉर्चुनेटली लवबर भैया नहीं होंगे। आज आई ओनली डिस्कस द सॉल्यूशंस। विनय, सुपर हार्ड, ओके। There is a problem with the first question. It should be in C++ always. Please check. Okay, I'll check. Cool. So I guess that the contest didn't go well with respect to uh, didn't go well. Like Bhaiya kidhar hai? So he will not be taking every class. Probably he'll be in taking the interview series for the end of this month. I believe like next to next interview series probably he'll be joining us. But it's most all the interview series I'll be there, but he'll be coming in some of them. सिर्फ सेकंड वाला ही हो पाया। माहिर चंद हार्ड, ओके। इट वाज फेयर बट डिफिकल्ट, ओके। मैथ्यू, थैंक्स फॉर द फीडबैक। ओके, सो एवरीवन इज सेइंग इट वाज वेरी हार्ड। कूल, देन आई थिंक विल हैव सम फन सॉल्विंग द प्रॉब्लम्स, राइट। कॉन्फिडेंस ही खत्म हो गया। अरे कॉन्फिडेंस इतना जल्दी क्यों खत्म हो रहा है? तो yeah, don't worry about it, it's just a contest, right? There are contests that will be hard, there are contests that will be easy. Similarly, in real life as well, there will be interviews that will be hard, there will be interviews that will be easy. These are all part of life. So what you should do is you should have some takeaway from it, that what went wrong, how to solve the questions, how so that you never, like if you get a similar question after later, you should never miss that, right? So that's something that should be a takeaway, not that you'll give up on your confidence and these things. Was greedy problem? Cool. Is it possible to do question work like the meeting rooms problem? uh yes, kind of, right. uh, let's go with the questions, right. Piyush, I'm checking. So it is, you're saying no, Java and Python are also allowed. There's a problem TLE in the first question. It should be in C++ solution. Oh, okay. There might be problem with respect to language, but I believe the testers have tested that. If there is, then again, like we cannot do anything if that's the problem right now because the contest has ended. But yeah, definitely I'll pass it to the team that they should be a bit careful with respect to time limits, right? The problems are really very intuitive. Thanks for the contest. Thoroughly enjoyed it. Okay. Thank you, Anumai. I think you are the only person who enjoyed it. Sir, voice is too low. Voice is too low. Can someone tell if you guys can hear me? I think there might be some problem on your end. A lot of interval based, very interesting. Yeah. Cool. Let me know if my voice is low. If you guys cannot hear me properly, in that case, I can do something. Otherwise, it might be a problem at your end. Who was that? Abhishek. Yeah, it might be a problem at your end. Can someone let me know if the voice is low? Yeah, clear. Cool. Okay, so let's without wasting time, let's actually dive into the questions again. Like I'll try to spend more time towards again, we'll also write the solution, we'll also write the code, but again the major focus will be towards the intuition, right? So please do not spam things like, hey, write in Java, write in Python, write in C++, these things, right? We'll only use only one language to write the code. But again, our main focus is to understand how to solve the problem. Code is something that you can write as well, right? If I don't write it, you will definitely, like, if once you understand it properly, you can always write the code for it. Cool. Okay, so powerful integer, you are given a 2D integer array interval whose length is n, where interval I is basically start to end, means all integers from start to end, inclusive of both the start and end, are also present. And also we are given an integer k. We have to return the powerful integer. Powerful integer is the integer that occurs at least k times, and if multiple integers have at least k occurrences, we have to return the maximum integer out of the lot. Okay, so we are given a few ranges. A range means that all the elements within that range, like a range is what? Some starting point to ending point, let's say 2 to 5. So all the elements between 2 to 5, including 2 and 5 as well, are present, right? So basically count plus plus for all the ranges. Now, uh, we are also given an integer k, right? We are also given an integer k. We have to return the powerful element. What is the powerful element? A element whose frequency is more than k, greater than equal to k. If there are multiple elements whose frequency is greater than equal to k, we'll have to give the maximum out of them. What is the maximum out of them? Okay, पार्ट स्पेलिंग गलत है भाई, क्या कर रहे हो? इट्स ओके, गलत हो गया होगा किसी से, इट्स ओके, क्वेश्चन पे ध्यान दो. If no integers occur at least k times, we have to return -1. So for example, 1 3 4 6 3 4, right? Let's see. 1 3 means 1 2 3, that is present, right? 1 3 means 1 2 3, that is present. 4 6 means 4 5 6 is present. 3 4 means 3 4 5 is present. So if you see which element is occurring more number of times, like at least k is 2. So 3 is occurring 3 times, because 1 2 3 one time, 4 5 6, no sorry, 2 times. Here 3 is not there. 3 4 5 3 4 again. So 2 times 3 is occurring. 4 is occurring how many times? 4 5 6 once here. 3 4 once here. So 2 times. So both of them are occurring 2 times. Any other element is not occurring 2 times. So we can see that the maximum out of them, there are two elements that are powerful, possibly powerful. Which one is the powerful? We'll take the maximum out of them. So maximum is 4. So the output should be 4. Okay, so this is the question. The range, the constraints are very important here. The constraints are 10 to the power 5 n. Intervals are in the order 1 to 10 to the power 9, and k is of the order 10 to the power 5. Okay, so this is the question. Okay, let's see how we can solve this. Okay, so firstly, what will be the brute force way? Let's start from the basics, right? What will be the brute force way to solve this problem? I think everyone can do this. Like, we are given ranges, right? Let's say 1 to 4 is given to us, 3 to 5 is given to us, 2 to 6 is given to us, right? And let's say 4 to 9 is given to us. So we are given k equals to 3, right? So we have to find all the elements that are occurring at least 3 times, and we have to then return the maximum out of them. Okay, so for the first range, what are the elements that are occurring? So what we can do is, in a brute force way, what we can do is, we can maintain a frequency array for all the elements, right? We can maintain a frequency array. So this is the frequency of 1, frequency of 2, frequency of 3, frequency of 4, frequency of 5, frequency of 6 7 8 9. Initially all the frequencies will be 0. In output of the test case 1621, I'll come to that. Just keep that handy. Once we are done with the explanation, I'll come to that. Okay, so okay, 1 4 1 4 means what we'll do is frequency will increase from 1 to 4. So initially everything is 0. 1 to 4 will be increased to 1. 1 2 3 4 is increased to 1. Others are 0. Now we have another range 3 to 5. So again 3 to 5 means these are present. So again, a better brute force can be, we can just extend this 1 to 4, we can just replace this with 1 2 3 4, right? Then 3 to 5 is basically 3 4 5. We are just expanding each of the ranges. 2 to 6 is 2 3 4 5 6. 4 to 9 is 4 5 6 7 8 9. And then we can count the frequency of each of the elements. If we don't want to do it like this, we can also maintain this frequency array, right? We can sort this. How to count this? We can sort this and find the, like, consecutive elements will be there, right? Similar elements will be consecutive, so we can find the count of each of them. If we don't want to do that, we can maintain this frequency array where we increase the count. So 3 to 5. So 3 to 5 is 3 count plus plus. It is 1 right now, it will become 2. 4 count plus plus, 4 will become 2, 5 will become 1, 6 will become 6 is not there. So 6 will not become anything. इरेजर थोड़ा छोटा कर सकते हैं क्या? ओके, नहीं हो सकता, चलो कोई दिक्कत नहीं. हाँ, सो 4, 5, 6. Right, so 5 became 1 as well. 2 to 6. So 2 frequency will be increased by 1, so it will become 2. 3 will be coming plus plus, so it will become 3. 4 will become 3. 5 will become 2. 6 will become 1. And then 4 to 9. So 4 will become 4. 5 will become 3. 6 will become 2. 7 will become 1. 8 will become 1. 9 will become 1. Something like this, right? So how many elements are there whose frequency is greater than 3? It will be 3, 4, 5, I think. So out of them, which is greatest, 5 is the maximum one, so we'll return 5 as the answer. So this is the brute force way. Again, this will not work because why? Because our A of I is of the order 10 to the power 9, right? If A of I was of the order 10 to the power 5, this would have worked, but as it is 10 to the power 9, it will not work. And again, this will not work anyways because it is n squared as well. You are not n squared, basically n into each interval length, right? So kind of like n into A of I. This is the complexity, right? Because you are traveling through all the intervals, right? So definitely this will not work. This is a brute force approach. But I think the brute force is clear with everyone. Let me know if you have any doubts with the brute force, right? Let's come to the optimal way. Now what we'll do is, okay, so whenever we are given intervals, right? Whenever we are given intervals, keep this in mind. Whenever we are given intervals, we should always remember what is point of, we should always consider the points of interest, right? We should only consider the points of interest. Okay, before we actually come to points of interest, so whenever we are given intervals or something, right? Whenever we are, so what we are essentially doing here, we are given a range L to R. How is the brute force N into A of I? In worst case, like what are we doing here? We are traveling through the entire range. We are given a L to R. We are traveling this entire range. There are n such ranges, and this difference will be at max A of I, like 0 to A of I. L can be 0, R can be A of I. So it will be in worst case N into A of I, approximately, right? Okay. So before we go ahead, we are given the ranges in the form of L to R, right? What essentially are we doing? What was the operation that we did in this? So first of all, we'll try to optimize one point, right? Optimize the point that initial complexity was n into A of I. Can we just get rid of this A of I factor, right? Can we just get rid of this A of I factor? This is the first thing that we want to do. N into A of I think it is clear. Why? Because we are traveling the entire range. Can we not travel the entire range and still make the update? So what are we doing essentially? We have this frequency array. We want to account for, like we want to increment the value, right? But we do not want to travel the entire range as well. So let's say there are ranges like this: 1 to 3, 2 to 6, and 5 to 7. So this is basically 1, 2, 3, 4, 5, 6, 7, and we'll take one more, 8. Okay. So earlier what we did, we traveled this entire range 1, 2, 3 and incremented them by +1, +1, +1 like that. Now instead what we'll do, whenever we have ranges like this, right? Whenever we have ranges, this is what? This is range update. This is what we are doing here, is we are doing a range update. And whenever we have things like range update and we can process it offline, like we do not immediately want the count. We want the count after all the updates are made, right? So whenever we can process it offline, what we can do is we can use a technique called A of L plus plus A of R plus 1 minus minus. What does this mean? Let's say you are taking a cumulative sum. You are taking a cumulative sum. थोड़ा रुक जाओ सभी, रुक जाओ, solution बता रहे, आराम से रुको. We are taking a cumulative sum from the front. When we reach L, let's say there is a range called L to R. When we reach L, our cumulative sum increases by 1 because A of L plus plus. When we reach R plus 1, our cumulative sum drops by 1, minus minus, right? So that means we have accounted, see, we're only within the range L to R. we have the plus 1 factor within our cumulative sum. So have you by hearted solution? No, I have solved similar problems a large number of times. So this is a very standard technique, right? This is a very standard technique to solve these type of problems whenever you have ranges and you have range updates. So what I'm trying to tell you, see, initially everything is 0. We have 1, 2, 3. So we will do, let's call this f, array is f. So we'll do f of 1 plus plus. So f of 1 becomes 1. F of 3 plus 1, not 3 but 3 plus 1 minus minus, that is f of 4 minus minus. Basically if 3 was not included, in that case we could have done 3 minus minus, but as 3 is also included within the range, so we'll do 3 plus 1 minus minus, that is 4 minus minus. I tried this approach but was giving TLA. अभी रुको, अभी भी solution पे नहीं आए, अभी just एक optimize कर दे. Wait for some time. I haven't discussed the final solution. I am incrementally going towards the final solution. Right? समझ नहीं आया? Jatin, follow this. Right? 1, 2, 3. समझ आ जाएगा. Just follow the example. 1, 2, 3. What we are doing is we are doing f of 1 plus plus. That is, it becomes 1. F of 3 plus 1 minus minus. So क्या कर रहे हैं? Every time we are doing f of L plus plus and f of R plus 1 minus minus. Why are we doing this? We will get that in some time. Just wait for some time. But we are doing this operation, right? So 4 minus minus. Now 2 to 6. F of 2 plus plus, it becomes 1. F of 6 plus 1, that is 7 minus minus. It will become minus 1. 5 to 7. F of 5 plus plus. F of 7 plus 1, 8 minus minus. Let's make it 4 to 7. Right? Let's make it 4 to 7. So, अरे यार ये delete हो जाएगा. Okay, let's make it 4 to 7. So we'll keep this to be 0. So f of 4 plus plus. So what is f of 4 right now? F of 4 is minus 1. So minus 1 plus 1 will become 0. So it will become 0 again. And f of 8 minus minus, minus 1. We have this. What is the advantage of having this? Just take the cumulative sum of this. Cumulative sum means just take the prefix sum for all the elements. See what happens. After we take the cumulative sum, 1, 2, 3, 4, 5, 6, 7, 8. Right? We are taking the prefix sum. So 1, it will come here 1. At 2, it will become whatever is at 1, f of 1 plus f of 2. So 1 plus 1 will be 2. We are taking the prefix sum. At 3, it is 0 right now. 3, it is 0. So it will get carried forward. It will become 2. At 4 also it is 0, so it will remain 2. At 5 also it is 0, so it will remain 2. At 6 also it is 0, it will remain 2. At 7 it is minus 1, so it will become 1. 2 minus 1 will become 1. At 8 it is minus 1, it will become 0. Now if you look carefully into this, this basically represents how many times each of the points have been visited. Let's check 1, 2, 3. So we have 1 getting visited 1 time, 2 is getting visited 1 time, 3 is getting visited 1 time. Then we have 2 to 6. 2 is getting visited 2 times, 3 is getting visited 2 times, 4 is getting visited 1 time, 5 is getting visited 1 time, 6 is getting visited 1 time. 4 to 7. 4 is getting visited 2 times, 5 is getting visited 2 times, 6 is getting visited 2 times, 7 is getting visited 1 time. Does this and this thing is the same? Are both of them same? Yes, it is. Because 1 is visited 1 time, it is also here. 2 is visited 2 times, 3 is visited 2 times, 4 is visited 2 times, 5 is visited 2 times, 6 is visited 2 times, 7 is visited 1 time, 8 is visited 0 times. Right? Okay, so this is, I think you got the idea. So what have we done? What is the complexity now? The complexity now is we are just traveling on all the ranges and we are doing f of L plus plus f of R plus 1 minus minus. So the complexity reduces to n, but there is an additional complexity here, that is traveling this entire array, and this array range will be of the range of the array element. So a of I. So it will become n plus a of I. Why n plus a of I? For updating, it will take n because we are just looping over the ranges. But when we are taking the cumulative sum, we are going through all the array element values actually possible. So it will be rather not a of I but max of a of I, whatever is the max of a of I possible, right? So n plus a of I, this is the total complexity. Now this will also not work. Why? Because a of I is of the order 10 to the power 9. If a of I is of the order 10 to the power 5, this solution would have worked. If a of I is of the order of 10 to the power 5, this solution would have worked, because then it would have been n plus a of I, that is 2 into 10 to the power 5, which is okay for us, right? So this would have worked if a of I is of the order 10 to the power 5. But as a of I is of the order 10 to the power 9, this will not work. Got the idea? You got this idea how this is happening? Now, if you want to understand the intuition, how we are getting the count, in case, like if you haven't got it yet and you want the intuition, the idea is pretty simple. What are we doing is, we are doing f of L plus plus and f of R plus 1 minus minus. So let's say we are taking the cumulative sum, right? So when we reach f of L, because of this range L to R, f of L plus plus, so there is a plus 1, at least a plus 1, there might be, it might be 4 as well, 5 as well, but for this L of L to R, the contribution is plus 1. When we reach L, our C sum increases by 1 because of this LR, right? Because of this LR, our C sum increases by 1. At R plus 1, our C sum was what? C sum plus 1, it decreases by 1 again. So it becomes C sum again. So if you see, in the range L to R, our C sum has a plus 1 because of this LR range. So that's why we are having the count. Okay. So this is there, but we saw that this will not work. Why this will not work? Because the complexity for this becomes n plus a of I, and our a of I factor is very large, 10 to the power 9. Okay, this brings us to the main optimization that we want to do, and the final optimization. We see that if a of I is of the order of 10 to the power 5, if a of I is of the order of 10 to the power 5 or 10 to the power 6 or 10 to the power 7, this would have worked. But as a of I is 10 to the power 9, this is not working, right? Do we actually need all these 10 to the power 9 elements? Do we need all the 10 to the power 9 elements? This is the question. The answer to this is no. We do not need all the 10 to the power 9 elements. This brings us to a very important concept that is called, you can either call it points of interest, or this is more generally called as coordinate compression, right? This is more generally called as coordinate compression. Why do we want to, what do we want to do here? Basically, what is coordinate compression? Coordinate compression means that you have a sample size, you have a set of elements. This is very large, let's say here 10 to the power 9. You are actually compressing these elements in a smaller segment of the order, let's say 10 to the power 5, right? Because we see that if you are able to bring down a of I from 10 to the power 9 to 10 to the power 5, our solution will work. So that is what coordinate compression will help us with. What is coordinate compression? Let's understand this. First of all, let's understand what is, like, why do we even need this? And yes, that's a very valid question. How can I say this, right? How can I say that do we need all the 10 to the power 9 elements, right? How can I say this? Well, I'm able to say this because the elements that matter to us are only the elements that we have in the ranges, right? All these terminal elements only matter to us. Why? I'll show you. See, 1 to 3, 4 to 6, 7 to 9, right? Not only the terminal element, but also plus 1 for them. Plus 1 for the right element, because that is where the count is getting decreased, right? So only the places where changes happen, only the places where you do f of L plus plus, only the possible L that can come here, or only the places where you do R plus 1 minus minus, only these possible R plus 1s, only these are our points of interest. Only these are important to us. And why is that? That is what I'll explain here. See, again, 1, 2, 3, the frequency is 1, 2, 3, 4 to 6, 7 to 9. Actually, there's no overlap. Let's create some overlap, right? So 1 to 6, 3 to 5, and 6 to 8, right? Let's see. So again, we'll write down the frequencies quickly. So 1, how many time 1 is occurring? 1 is occurring one time. 2 is occurring one time. For 1 to 6 only we are doing. 3 is occurring one time. 4 is occurring one time. 5 is occurring one time. 6 is occurring one time. Now we come to 3 to 5. 3 is occurring 2 times. 4 is occurring 2 times. 5 is occurring 2 times. Now we come to 6 to 8. 6 is occurring 2 times. 7 is occurring 1 time. 8 is occurring 1 time. If you look into this carefully, right? If you look into this carefully, what are the elements that are there? Or what are the elements where we have done L plus plus and R minus minus? The elements where we have done is 1, 6 is also important actually. 6 plus 1 is 7, 3, 5 plus 1 is 6, so 6 is already there. 6 is already there. 8 plus 1 is 9. I can say that only these points are important. Why is that? Just see. 1 has 1. 2 also has the same value that of 1. Right? So whatever we can do with 1, we can also do the same with 2 as well. Similarly, 3 has a value of 2. 4 has a value of 2, right? And 4 is nowhere here. 4 is not in our point of interest. So we see that actually 4 and 3 are the same thing. 5 and 3 are the same thing. 6 and 3 are the same thing. Although 6 is not the same, because 6 is the largest. 6 will be the largest element. So if you see this 3 and 4, these are kind of irrelevant. They are kind of trapped between 3 and 5, 3 and 6. 3 and 6 will be the main points of interest for us. 4 and 5 are just getting trapped in between. So we do not really care about them. Right? Similarly, 7 is important for us. 8 is again not important for us, right? Because we can keep, because 9 is important for us, so we can keep 8 as well important for us actually, because it marks the ending. But anyways, you get the idea, right? That this 4, 5, it is kind of in between 3 and 6. So it doesn't give us any advantage of storing the value of 4 and 5, right? And that is because the reason for the middle elements being not important is we are not doing any operation on the middle element. If you see, we are only doing operation at L and we are only doing operation at R plus 1. So what is important to us is L, R and R plus 1. This will help us cover everything. We do not need all the elements between L and R. All the elements between L and R, that is L plus 1 to R minus 1, these elements are not important to us because our answer will be R. If there is the answer, our answer will be R, not in between. Provided there is no other range in between, in that case, the corresponding entries will come in, right? Okay. Now, this brings us to how many points of interest can there be, right? So we see that for a range L to R, we get 3 points of interest, right? 3 points of interest. That being L, R and R plus 1. We are getting these 3 points of interest, right? So for n ranges, how many points of interest do we get? We get n into 3 points of interest at max. So this is 3n. That is 3 into 10 to the power 5, right? So we have essentially compressed 10 to the power 9 values to 3 into 10 to the power 5 values. Now n plus ai with this compressed value, that is within 3 into 10 to the power 5, n plus ai will work now because the total complexity will just become 4 into 10 to the power 5, right? 4 into 10 to the power 5, which will work for us. So this is the entire idea, right? This is the entire idea. We have reduced. So the first step that we did, let's quickly recall, what did we do? So the first step that we did was, first step was from n into a of I, initial complexity, we reduced it to n plus a of I using what? Using the f of L plus plus f of R plus 1 minus minus approach. The second that we did was a of I range was 10 to the power 9. From here we reduced the points of interest, not a of I but points of interest, to 10 to the power 5, rather 3 into 10 to the power 5. And after this we can solve the problem easily. Okay, so let's try to write the code for this. I hope this makes sense now. Yeah. And how to write the code again? I'll write the code. So can you explain 4 into 10 to the power 5 part? Yes, sure. So what was the complexity that we saw here? We saw here n plus a of I, right? So we saw that only 3 points of interest are there per range. That is L, R and R plus 1. For the range L to R, we are only interested in L, R and R plus 1. So total there will be 3 per range. How many ranges are there? 3 into n. So total complexity was n plus a of I. So total number of points we now have is 3 into n. So 3 into n plus n. Total complexity, that is 4 into n, right? Cool. So let's try to write the code here now. Okay, first thing that we want to do is we want to reduce the third space from 10 to the power 9 to 10 to the power 5 just by taking the points of interest. So what we'll do is, first of all, we'll maintain a set of the values, set int, let's call it POIs, point of interest, right? POIs. So for int I equals to 0, I less than intervals dot size, I less than n, rather I plus plus. So what do we get? We get the L. L is equals to what? Intervals of I0. Int R equals to intervals of I1. Right? We'll get L and R. Now what is our point of interest? Our point of interest is, we'll insert L, we'll insert R, and we'll insert R plus 1. Again, you get the idea why are we using a set, right? Because we just want the unique values. We just want the unique points of interest, right? So we'll insert L, R, and we'll insert R plus 1. So these are our points of interest. Now this set contains all possible unique points of interest for us. So now we will map them. They are of the order 10 to the power 9. We'll map them from 1 to 10 to the power 5 or 3 into 10 to the power 5, right? So what we'll do is we'll maintain a count equals to 1. And we'll also map there, map int compressed, the compressed value for them, right? Also okay, I'll come to that later, but let's actually do this, right? So for int x belongs to, so we are looping over all the elements in the points of interest. So what we are doing is we are compressed value of x equals to count plus plus, right? Compressed values of x equals to count plus plus. So what we are doing essentially is we are giving them, mapping them like 1, 2, 3, 4 like this. Let's say our points of interest are 10, 100 and 1000. So in this case what we do is 10 gets mapped to 1, right? 100 gets mapped to 2 and 1000 gets mapped to 3. So we are mapping the range from 1 to 1000 to 1 to 3 only, right? So that's exactly what we're doing here. We are mapping within 10 to the and this will not be more than 10 to the power 5, right? 3 into 10 to the power 5. So we have done the mapping, right? Now what we'll do is, now we'll do the approach that we talked about. We'll maintain the hash map. So what is the maximum value? What is the maximum value of a point of interest, or what is the maximum value to which a point of interest got mapped? That is basically count minus 1, because we are doing count plus plus every time. So count minus 1 will be that. So our hash map size will be what? Count minus 1, right? Or we'll call it a frequency table. So in frequency of count, and initially everything is 0, right? So for int, again we'll go through all the ranges. Let's copy this loop. We'll go through all the ranges again. But here now, instead of using L, we will use the compressed L. Like, so int CL compressed L is equals to what? compressed value for L. Compressed value for L. Similarly, in CR is equals to the compressed value for R plus 1, because we want to do f of a frequency of L plus plus frequency of R plus 1 minus minus. So we want the R plus 1, right? So it will be R plus 1. And remember, we have inserted R plus 1 as well in the point of interest. So it will definitely be there, right? So CR, and what we'll do is frequency of CL plus plus, frequency of CR minus minus. Now note, okay, we'll come to that later. Now what we'll do is we'll take the cumulative sum. So for int I equals to 1, I less than CNT, I plus plus, that's the size. So frequency of I plus equals to frequency of I minus 1. We are just taking the cumulative sum. And now we know what are the elements that are there that is greater than, who are greater than k, right? But if we return directly from here, how do we find the element? How do we find the maximum element? So we'll start from the back. For int I equals to count minus 1, I greater than equal to 0, I minus minus. If frequency of I equals to is greater than equal to k, then we can return I. Then we can just return I. But this will not work. Why? Because we are returning the compressed value. We want the actual value, right? So for that, we also have to maintain the uncompressed values as well. So uncompression logic as well. So uncompression mapping, or uncompression map, right? So what we'll do here is uncompression map of compressed value of x is equals to x, right? So we'll map the reverse way as well, or we'll call it a reverse map, right? We can also call it a reverse map. Let's call it a reverse map, reverse compression, and we'll do a reverse compression map here, reverse compression. So reverse compression for the compressed value, basically it means that this compressed value of x, whatever it is, 1 2 3 4, that actually was the actual element was x that was compressed, right? So we want to return the reverse compression of I, and that should do it. How L are, please rewind the video and see, I've already explained that. Basically we have talked about points of interest. Now what are the points of interest for us? L, R and R plus 1, because we are only updating L, we are updating R plus 1, and R because R is the last element of the range, so we need the maximum one, so R is also important for us, right? So L, R and R plus 1, these are only the 3 important points for us. So if you see we are getting 4, our expected is 4. Let's try to submit this. I hope this works. Let's see. Okay, we're getting a wrong answer for some reason. Okay, so if it is not found, right? If it is not found, why is it returning 1 then? Return minus 1. Return minus 1, and let's try this out. We haven't added this condition. Let's try this out once. So yeah, now it's correct. So I think by default it returned 1. Cool. Okay, it might TLE. Okay, TLE for some reason. Let's see. 10 to the power 5. Cool. We can do a couple of optimization on top of this. Instead of set, we can store it in a vector. We can, like, no, not a lot of advantage for that, but okay. So instead of set, let's store it in a vector, right? So vector int POIs. So what we'll do is POIs dot pushback, POIs dot pushback, POIs dot pushback, and here instead of map we can maintain unordered map, and here also we can do a unordered map, right? Firstly we should do a sorting, so sort pois.begin, pois.end. We'll sort them and then we'll store them, so they're sorted in increasing order. So now what we'll do, first of all we'll check if not compressed value of x, if not compressed value of x only, because now there will be duplicate. With z there would not have been duplicates, but now there will be duplicates, so we have to be careful about mapping. So compressed value of x is this, reverse compression is this, yeah, count plus plus, frequency is okay, this part is okay, frequency and reverse compression, cool. Let's try to run this now. We'll compile. Sorting method, first array inserted all points ln and then sorting the array for looping, decrease the counter. Okay, not sure if this will also work, but this should have been the logic. Okay, so this is done, right? If you see, this is done. So this was the logic. Again, like small optimizations, instead of map use unordered map, instead of set maybe use vector, right? And sort them. So yeah, small optimizations, but you'll get the easy. Cool. So that's the first question. I hope that you guys have understood and a lot of things to learn. So just remember one thing. I'll just like conclude the first one with a small suggestion. So let's just erase this, right? Okay, let me know if it is clear with everyone. Like if it makes sense what I have done, because this is very important, right? This technique is very important. This can be used in a lot of places, right? So whenever you have ranges, just remember this. First thing, whenever you have ranges, right? Whenever you have to do something with ranges, let's say you do not want overlapping ranges, anything, right? Or how many ranges are overlapping at a point, anything like that. Always try to go towards the concept of f of L plus plus, f of r plus 1 minus minus, because in this case that it becomes very easy, right? It becomes very easy to solve the problem. I'm not saying it will be always valid, but in most of the cases it will be valid. Unless it is a DP problem, generally this will always work, right? So whenever you have ranges, always try to go towards this. Second is, whenever you have ranges, right? Whenever you have ranges or you have big values, right? You see that you have big values, but not all of, try to figure out if all of them are really important, right? Try to figure out if all of them are really important. If not, you can always go for coordinate compression, right? Okay, I'll actually give an example. Maybe you can try this, try thinking about this as well, right? But again, like I'll not discuss this. So a example question can be that let's say we are given n ranges, right? We are given n ranges of the form L to R, right? So you have to tell, yeah, find the point where, or rather, yeah, find the number of points, find the number of points where at least k ranges overlap, right? So you are given n ranges L to R. What you have to do is you have to find the number of points, right? You have to find the number of points where at least k ranges overlap. The constraints are L is 10 to the power 9, L and R is 10 to the power 9, and N is 10 to the power 5. So you have to find the total number of points where at least k ranges overlap. So try solving this on your own, yourself. You have learned about coordinate compression. If not, rewatch the video again. But yeah, like try to do this one, right? So that's the idea. Okay, let's go to the next question. We'll go to max points. We can still use R for the number of, not so trivial, because just think why R minus L plus 1 will not work. Like R minus L plus 1 will work definitely, but R minus L plus 1 should be the actual RL, right? Not the compressed RL. So you have to be a bit careful about that, but otherwise, yes, the same concept will apply. Okay. So try this on your end, write the code and see if this is working. Cool. Let's go to the second problem. You are given a 2D integer array ranges whose length n where ranges of I is start to of I to end of I and points of I. Also, what is the range? 10 to the power 9. Okay. Means all integers from start of I to end of I, inclusive start of I and end of I, are present. We get okay, are present, and we get coins of I amount of coins if we select the ith range. Okay, you can select at most two intervals so that you collect the maximum coins, but if you select two ranges, that two ranges should not intersect or overlap with each other. Okay, that two ranges should not intersect or overlap with each other, but they can touch each other. So as given here, you can select max two ranges. They should not intersect with each other, but they can touch each other. Touch means one range can end at 3, the other range can begin at 3. That works, that is touching. But they cannot overlap, means one range can end at 3, the other, let's say a range is there 1 to 3, we cannot take another range that is 2 to 4 because they will overlap. Yes, they were pretty standard. Yes, exactly. Like these are very standard problems. Again, like if you know the technique, you know how to solve them. You can select max two ranges and they should not intersect with each other, but they can touch themselves. Okay, I'll do one thing here. I'll not write the code for this. I'll not write the code for this. The reason being, this is again a very similar problem as the last one. This will also, again, if you see ranges, we have ranges. The ranges are in the range 10 to the power 9. So definitely we will use something like coordinate compression, right? Only twist here is we want to maximize the number of points. So how can we do that? I'll just quickly give you the solution. I'll tell you how to solve this, but we will not write the code for this. Okay, just try to write the code for this yourself, and after that we can like that will help you, right? That will definitely help you. So write it yourself. Cool. Okay, so let's understand what exactly happened. So we are given n ranges, right? We are given n ranges of the for L to R. We are given n ranges of the for L to R. We have to choose two out of them. We just have to choose two ranges, and the only condition is we have to maximize the number of coins. Maximize the number of coins, and each range has a coin I associated with it. Each range has a coin I associated with it. So what is the maximum number of coins that we can get? Condition being there should be no overlapping or intersection, but there can be touching, like they can touch each other. The two ranges can touch each other, but they cannot intersect or overlap. What do we mean by touching? Let's say we have a range 1 to 3 and we have another range 3 to 5. This is called touching. They are touching at this point. The end of one range and the beginning of one range can be same. The second range can be same that we choose. Overlap means what? We have a range 1 to 3 and we have another range 2 to 4. This is overlap. This is overlap, right? This is overlap happening here. So overlap is not okay. Touching is okay. Cool. Okay. How do we solve this again? Let's say, first of all, forget about 10 to the power 9. The constraint was L and R is 10 to the power 9. Forget about this, right? Just assume that L and R is like of the order 10 to the power 5 or something like that. How can we solve it then? If we are able to solve it for this, we can bring it down to this using coordinate compression. We have already learned about that in the previous question. Cool. let's assume this is the condition. What do we want? We want to choose two ranges to maximize the number of coins. Two ranges. Let's say we fix one range. If we fix one range, let's say one range means, what is the range? It is a range that is L to R. We have fixed the range L to R, right? We have fixed the range L to R. What does this mean? We want to find, what do we want to find? What is the max coins we can get if one of the ranges is whatever range we have chosen here. Let's call it Q, or let's call it R. One of the ranges is R. If one of the ranges is R, what is the maximum number of coins that we can get? So we can run this for all possible ranges. For all the ranges, we can run this exact algorithm that for each range we'll find what is the maximum sum we can get if one of the ranges is this range, and then the total maximum that we get out of them will be the answer, right? So we just have to solve this problem, that is, given a range, let's say the problem is now modified a bit, that is, we are given one of the ranges is given to us, that is L to R. We have to figure out the second range. We have to figure out the second range such that we get the maximum coins. This means that one of the ranges is fixed, right? So the number of coins we get out of it is also fixed. What was the total number of coins? Ci plus Cj. This was the total number of coins we would have got if we chose I and j. Now Ci is already fixed. Cj is only the variable quantity. We want to maximize the number of coins. So what does this mean? This means that as this is fixed, we can take it out. C of I plus the maximum of C of j. That is, we want to find the maximum coins that we can get from a range, right? The j for which we can get the maximum number of coins. The only condition we have to be careful about is this C of j should not intersect C of I. J should not intersect I. J should not intersect I. This is the only condition we have to be careful about. So what can we do to have this? What can we do? We can do a prefix suffix max, right? We can do a prefix suffix max. Why can we do this? What is essentially that we want? Let's say we have chosen I. I is in the range L to R. So basically we want the maximum number of coins from the range 0 to L minus 1, because that ends at L. This is the ending point, right? Sorry, let me write it like this. Max number of coins we can get from ranges ending where? Ending at L minus 1. Max number of coins we can get from ranges ending at L minus 1, because if the, or ending at L, rather ending at L, because they can touch each other, right? If the ranges are ending at L, that means our range is starting from L, right? So definitely they will not intersect. They will at worst case touch each other, which is fine with us. So max number of coins we can get from the ranges ending at L. That is one part. Second part, this part is also valid, right? This part is also valid. This part is valid. This is L to R. This part is also valid. So also the max number of coins we can get from ranges starting. This is starting now. Starting at R. Max number of coins we can get from ranges starting at or beyond R. At or beyond R. Similarly, at or before L. Again, what we have done here, let's understand this again one more time. We have this range L to R. We want to find the maximum number of coins we can get with another range that is not intersecting with this. So what is the valid? What are the valid ranges? The ranges that end at L, those ranges are valid. The ranges that start at R, these ranges are valid. So the maximum that we can get from here, from the ranges that are ending at L, versus the maximum we can get from here, the ranges that are starting at R, right? So that is the maximum, and we want the maximum out of them. So we want the maximum of these two things. We want the maximum of these two things. So we can use something like a prefix suffix max, that is for each range L to R, we will maintain their values. We'll maintain their values, right? And then we'll do a prefix, that is, let's call it P. P of I. P of I will contain what? P of I can contain the max number of coins. Max number of coins for ranges ending at or before I. P of I will contain the max number of coins of ranges ending at or before I. So how will we do this? It is basically equals to P of I minus 1 plus all the ranges that are, sorry, max of, not plus, max of P of I minus 1, or all the ranges that are what? All the ranges that are ending at I. Only I is not computed, right? I minus 1 will always, or max C of j, where C of j means the ranges that are ending at I, C of I rather, right? C of I, max of C of I, of the ranges that are ending at I. Okay, can you tell me which part you didn't understand? I can repeat again. So maximum number of coins for the ranges, I think you get the idea, right? We are just doing a prefix suffix sum. We just want, again, what do we want? What was the question demanding? The question was demanding, we want the maximum number of coins from two ranges. What I'm saying is, fix one of the ranges, right? You can loop over all possible ranges. So when you loop over all possible ranges, fix that range that you are at right now. Now you want the second range such that the number of coins is maximized. This is a standard way, right? You are said, like, you must have seen questions like, you want to find a of I plus a of j, maximum a of I plus a of j, like this, right? Or maximum something, like some condition like this, where you fix one of the elements of the array and you search for the other element, right? Or max, where some property is satisfied, like a of I equals to a of j, maximum distance, these things. What do? You fix one of the elements and then you search for the other element. You fix a of I and you search for a of j using binary search or something, or prefix sum or something like that. The same thing we are doing here. Question that we are given is, create a map of hold the ranges. Not necessarily. See, not necessarily. We want the max C of I, right? We want the max C of I. Let's say, can we do something like this? We just want the maximum out of them. So can we maintain another array called max of I, which is basically the max value or max coins for a range ending exactly at I? How can we populate this? We can just loop over all the ranges for range in ranges. We can loop over the ranges and we can just do max I, max of range of right is equals to max of whatever value is present, max of range dot right, or the current coins. We can do like this. We can do like this, right? We can do like this. ठीक है ना? So we can just maintain this max of I. We just care about the max of I, right? We do not care about the other elements. So we can just loop over all the ranges. We can update this max of I. Again, what is max of I? Max points of a range that ends exactly at I, right? So then we can easily compute. Basically, this will become max of I after this. P of I minus 1 comma max of I, right? So this is how we can do. And now, okay, let me repeat again quickly once. So this is a very standard technique, right? This is a very standard technique whenever you have to find two elements, right? Like let's say two elements. Okay, let's take a similar problem, right? Let's take a similar problem. So you are given an array. You are given an array A. You have to find two. You have to count the pair of elements. Number of pair of elements such that their sum is divisible by 10. Their sum is divisible by k or 10. Their sum is divisible by k. You are given an array A. You have to count the number of pair of element whose sum is divisible by k. What do you do with this problem? You fix a A of I. What is the condition again? Let's say I and j are the two elements. I and j are the two elements that will satisfy this condition. What should be the condition? A of I plus A of j modulo k should be equals to 0. That is, A of I modulo k, whatever this gives us, A of j modulo k should be the complementary of that, right? So let's say k is 5. So if A of I modulo k gave us 2, A of j modulo k should give us 3, such that 3 plus 2 becomes 5. So it becomes divisible by 5, right? So we fix one of the elements. That is, we fix A of I. And we try to find A of j. How do we find A of j? We maintain something like a hash map or something. Like we will maintain A of j modulo k in the hash map, right? And then for A of I, we get A of I modulo k minus. So we search for this in the hash map, k minus A of I modulo k. If you do not know this, I'll recommend you solve LeetCode questions more, right? So this is how we do. This is a very popular approach. You fix one of the elements. You then search somehow, binary search, or you maintain a hash map or something, or prefix sum or something, right, to get the other element. Same thing we are doing here. We just want two ranges, right? We just want two ranges with maximum number of coins and such that they are not intersecting. What I am saying, okay, fix one range L2R, right? Let's give it a value. If you don't understand L2R, let me give it a value 6 to 10. Let's say we are fixing this range 6 to 10, and let's say we know the number of coins we get if we fix this range is 4. What is the maximum number of coins? This 4 number of coins is fixed, right? This 4 number of coins is fixed. Which part will be variable? The second one, the second range that we'll choose, that is variable. ये 4 तो fixed है ना, 4 तो मिलेगा ही. अगर first एक range is 6 to 10, we will always get this 4. The second 4 plus x, this x is variable. What is x again? A coin from the number of coins that we can get from a range that does not intersect with this 6 to 10. What are the ranges that does not intersect with 6 to 10? The ranges that start from here. The ranges that start from here, from 10, they do not intersect, right? अगर इधर से start करता है ये तो intersect कर रहा है. Only जो 10 से start करता है वो intersect नहीं करेगा. Similarly, the ranges that end at 6 do not intersect. The ranges that end at 6 will not intersect. अगर रेंज ऐसे चला गया 6 के बाद चला गया तो इंटरसेक्ट कर रहा है, बट जो 6 पे एंड कर रहा है दैट विल नॉट इंटरसेक्ट. दे विल टच but they will not intersect, and we only care about intersection. Touching is allowed. Okay, so what do we want? Again, we want to maximize this value, right? We want to get the maximum number of coins. इसमें से variable कौन सा part है? Variable is x. So this means we can write it like this as well, 4 plus max of x or overall possible x. ऐसे भी लिख सकते हैं. What is max of x? The maximum number of coins we can get here, that is ranges that are ending at 6. What are these? Ranges ending at or before 6. The maximum number of coins from here or from here. What is this? Ranges starting at or after 10. इसका जो मैक्स मिलेगा that will be x. ठीक है, so then we'll have two non overlapping intervals. तो इसको मेंटेन करने के लिए क्या कर सकते हैं? How can we maintain this? We can have something called P of I. What will P of I store? P of I will store exactly this value. The maximum coins we can get from ranges ending at or before I. P of I will give us this maximum coins we can get from ranges ending at or before I. Similarly, let's call S of I. S of I will be giving what? Maximum coins we can get from ranges ending or starting at or after I. This is S of I. कैसे निकालना है वो आते हैं बाद में, but if we have these two arrays, can we compute our answer? Yes, we can. How can we compute our answer? Fix the range. So loop over all ranges. For range in ranges, figure out the L and R. So you have the L and R. Now for this range, you will take the maximum of P of L and S of R, and you will add coin of I to the answer. So coin of range to the answer. ये तो फिक्स्ड वैल्यू है, coin of range तो फिक्स्ड वैल्यू, because I'm fixing this range, and your answer will be the max of all possible such ranges. Answer equals to max of answer, comma this thing. हो गया. अब इसको कैसे कैलकुलेट कर ले? P of I को S of I को कैसे कैलकुलेट कर ले? प्रीफिक्स सम, प्रीफिक्स मैक्स का फिक्स मैक्स कुछ है ही नहीं इसमें. P of I is what? मैक्सिमम कॉइंस. अगेन डीपी यूज करेंगे. प्रीफिक्स सम इज बेसिकली डीपी, राइट? प्रीफिक्स मैक्स इज डीपी. सो वही कंसेप्ट यूज करेंगे. P of I is equals to, what is P of I again? Max coins we can get from the ranges ending at or before I. Max coins we can get for ranges ending at or before I. So P of I will be what? P of I minus 1. What will be P of I minus 1? Same definition, max coins from the ranges we can get that are ending at or before I minus 1, plus max of I. What is max of I? Max of I is the maximum coin we can get from a range that is ending at I exactly. वो तो easily calculate कर सकते हैं. Figure out how we can calculate max of I, but this will be, sorry, not plus, comma, the max of this, that will be P of I. Similarly S of I भी similarly हो जाएगा, right? So this is how we can compute. अभी the only problem here is that we are taking the ranges L and R, we are computing P of I, S of I, everything goes of the order of A of I, right? And A of I is 10 to the power 9. So again we have learned about coordinate compression. We can bring it down to 10 to the power 5. So that is how we can solve this problem. Anyone has any doubts now? What will be the output for 2, 1, 1, 2, 1, 1, 3? You cannot take two ranges. So it should be minus 1 or something. Whatever is given, like when you cannot take two ranges. Or otherwise the question will tell that you can always take two ranges, right? So one of them has to be true. Either you cannot take two ranges, so in that case there will be some output given to you like minus 1 or something like that, or you can always take two ranges. In that case this input is not valid. All right, anyone has any doubts with this? Code you will have to write yourself. I'll not write it because again, same thing, coordinate compression, only a few things are additional, but they are also like related problems. You must have solved related problems, like right, like prefix max, suffix max, you must have already done that, so there's no point of writing it again. Try to write it yourself. It is a good question overall, so you will have to write some code, uh, but that's the concept. Oh, it says at most two ranges. I thought it was given two ranges, at most two intervals. In that case, you will just choose the one. Like if you cannot choose two intervals, you will choose the one with the maximum value, right? Yes, at max two intervals. Yes, you will just choose the one with the maximum value. So the answer will be whatever it is, like 3. Yes. Question 3. Yes, question 3 will solve. Question 3 will solve as well as write the code. But question 2, I'm not writing the code. I hope it is clear with everyone. Let me know if it is not clear. Then we'll go to question 3. Everyone got the idea about how to solve this? I'll recommend you to try solving it yourself. Cool. Let me know if anyone has any doubts. Otherwise, we'll go with question 3, which is this is a very good question actually. So we'll try to solve this. Cool. Okay, so let's read the problem statement then. Let me just increase this if no one has doubts. Okay, so given an array locations of size n, right? We are given an array locations of size n, where locations of I represents the location of the ith fruit on the x-axis, and we are also given array of types where type I is an integer, which represents what is the type of the ith fruit. So we have a x-axis, we have some fruits placed on x-axis. X-axis is what? It is just a line. Just think about it. On the floor or on the road, right? On the road, you are just placing fruits at some points, and the road is marked, right? Like 1, 2, 3, 4, like that. It is marked, and you are placing fruits at some points. So basically, location of I is where in the road or where in the x-axis the ith fruit is placed. Similarly, type of I is what is the type of the ith fruit. You are initially at coordinate 0. So you are standing at coordinate 0 initially. You have to collect all fruits and return back to coordinate 0 again, right? So you have to collect all the fruits and return to coordinate 0 again. To move 1 unit on x-axis, it requires 1 second of time. Okay, so to move 1 unit of x-axis, it requires 1 second of time. It is understandable. The only condition is that you have to collect the fruits in non-decreasing or increasing order of their types. That is, you have to collect the fruits, like first you have to collect fruit of type 1, then you have to collect fruit of type 2, all the fruits of type 2, then you have to collect all the fruits of type 3, and like that. So you cannot come back to 1 again. You have to go in a non-decreasing fashion. For example, if ith fruit has type 1, jth fruit has type 2, ith fruit must be picked before the jth fruit. So what you have to do, again, question I think is not clear, but yeah, what you have to do is you have to you have to give the minimum number of time needed to collect all the fruits, or minimum number of moves needed to collect all the fruits, right? 1 second, yeah, minimum number of seconds needed to collect all the fruits, provided you collect all the fruits in non-decreasing fashion, that is 1, 2, 3, type 1, 2, 3, like that. And you start from x-axis, you have to start from 0 of x-axis, you have to end at 0 of x-axis, right? So what is the minimum time needed to collect all the fruits? That is the question. For example, 1, 3, 5, 7 locations are 1, 3, 5, 7 and 1, 2, 3, 1. Okay, let's understand this by drawing. 1357. This is the x-axis. This is 0, 1, 2, 3, 4, 5, 6, 7. Right. 1357. Now we'll write the fruits. So where are the fruits? Fruits are at types are 1, 2, 3, 1. 1, 2, 3, 1. So 1, 2, 3, 1. So this is how the fruits are placed. So what we can do is, in the first, like at first, we have to collect all the, first of all, we have to collect all the ones. So what do we do? From 0, we move to 1. Right. So let's add to our seconds as well. So 1 second is needed. From 1, we have to collect this one as well, 7 as well. So from 1, we move to 7. So that needs how much seconds? 6 seconds. 7 minus 1. Plus, now we can have to collect 2. From 7, we have to collect 2. So we come down back to 2. How much seconds is needed here? 7 minus 3, 4. From 2, we have to collect 3. So we take this. So 2 plus 2 seconds. And from here, we have to return back to 0. So we return back to 0. So this takes 5 seconds more. So what is the total time taken? 6 plus 1, 7, 11, 12, 13, plus 5 is 18. So total we take 18 seconds and we cannot take less than that. If you note, there are multiple possible ways we can move, right? Here at least there are 2, like here we do not have multiple, but generally we will have multiple possible ways. For example, here we have 2 ways. So 1, 2, 3. The second way of moving can be, but that will be worse actually. But again, let me show you. The second way can be, from 0 we can directly go to this one, right? Then we can come to this one. Then from here we can go to 2. Then here we can go to 3 and come back to 0. So this is also what we can do, but this will take more time than 18 seconds. So that's why 18 seconds will be the answer, and there is no other move possible here, right? So yeah, so this is the idea. How do we solve this? Okay, how do we solve this? Let's understand. Okay, before we start solving, we have to understand a couple of things, right? First thing, again, what are the points that matter? What are the points? Let's say for a given type, let's say only one type of element is there. Only one type of element is there. Only one type is there. Let's call it type equals to 1. Only one type of element is there. And let's say they are at index 1, 2, 5, minus 3. One, 1, 3. Yes, sorry, answer will be 5. Yes, because they are touching. They are not overlapping again. Remember, touching, they're touching. Touching and overlapping is different. As what you have given is points just. So points will never overlap, they will always touch each other. But if you have something like ranges, this is overlapping, but this is touching, right? This is touching. Like this is, they are touching here. So for you, it will be 5 because they are touching. Sorry, my bad. Cool. Anyways, what are the points that are important here? We have to find, we are only given one type and we have to find the minimum time needed, right? So how will we collect? We will, from here, we'll go to 5. And from here, we can come down to minus 3. And from here, we can come down to 0. So that is one way. And when we go to 5, we can collect 1 and 2 as well. Another way can be, Another way can be we can go to minus 3 first. From here we can go to 5, and from 5 we can come back to minus 0. So that can be another way. So if you notice carefully, what are the points for a given type? For a given type, we just have one type here. For a given type, what are the points that matter? The points that matter is only the, for a given type, what are the points that matter? Only the minimum and the maximum, right? Only the minimum and the maximum. Why? Because in the number line, let's say maximum is here, minimum is here, you will go to maximum, and in route you will collect all the fruits that are coming in between 0 and maximum or any location. Similarly, after that you will go to the minimum, and then you will come back, something like that, right? Again, this is for only one time. You do not come back every time. You have to start from the first, you have to start at 0 from for the first time, and you have to end at 0 for the second time, at the last time, sorry, after having the last fruit. So for a given type, what matters to us is only the maximum and the minimum. So what we'll do is, first of all, we'll group all the points. So first thing that we'll do is we'll group all the ranges, sorry, all the point apples, all the fruits by types, and for each type just retain the minimum and the maximum. Minimum and the maximum x coordinate for that type of fruit, right? So we can maintain that in some variable called mean of type and max of type, like this. Okay, so that's the first thing that we'll do. Okay, now let's understand how do we solve this. Now we see that there are multiple possible moves, right? So definitely a greedy solution will not work. You can try figuring out if you can do a greedy solution, but it will not work. So next time, whenever we have something like minimization, maximization, and we see that there are lots of possibilities, it's better for us to go towards the DP solution, right? So we'll try to formulate a DP solution. What is the DP solution? Let's say if, again, if you think about it carefully, n, where n is the number of fruits, n doesn't matter. What matters is you are collecting the fruits in incremental order of their types. So if, let's say, first variable is type, that is, we'll define what this is, type, and second variable is, so when we are going from one fruit to the next fruit, yes, when we are going from one type, yes, that's a very good catch actually, and very good understanding. Let's say we are somewhere here, right? We are somewhere in the number line. Let's say this is type t minus 1, and next we are going to type t, and the maximum and minimum is here for type t. So from t minus 1, we can either decide to go to this one, type t, this is the last fruit, let's say for t minus 1. Either we can decide to go to this one, and then from here we can come here and then go to t plus 1, or we can decide to go to this one, and from here we can come down to here. Both of them are possible, and then go to t plus 1, right? So that's exactly what we'll do. So f of type is what? Type is basically what are the types that are left, right? And second will be flag. Flag can be 0 or 1. Flag can be 0 or 1. Why flag? Because for every type, we just have two possible states, right? Either we have ended at the minimum, or we will be ending at the maximum. Either we'll end at the minimum or we'll end at the maximum. Nothing else, right? So we just need type that is 2, 0 or 1. So what does this represent? This tells that what is the time? What is the time needed to collect all fruits? What is the time needed to collect all fruits of type? Actually, instead of type, let's call it t, right? So that is better. So t comma flag. What is the time needed to collect all the fruits of type t greater than equal to t? Type greater than equal to t, because we will be proceeding in an incremental fashion, that is type 1, t minus 1 should be computed, or t minus 1 should be obtained before we are going to type t. So what is the time needed to collect all the fruits of type greater than equal to t when for type t minus 1 we ended at flag? That is, what is the minimum time? Okay, let's understand this with an example, right? Let's say at some point we are at f4 comma 0, and let's say there are total 7 types available with us. Total 7 types available with us. We are at f4 comma 0. What does this mean? This means that what is the time needed to collect all the fruits of type 4, 5, 6, 7? What is the minimum time needed to collect all the fruits of type 4, 5, 6, 7, provided that for type 3, we ended at the minimum of 3. Minimum of 3 means what was the minimum index where a type 3 fruit was present? So that is F40. For 3, we have ended at the minimum of 3. Similarly, F41 is what? What is the time needed to collect all the fruits of type 4, 5, 6, 7, provided for type 4, for type 3, we ended at the maximum of 3, right? So let's say this is type 3, this is the minimum, this is the maximum, so mean 3, this is the maximum of type 3, and mean 4, and here we have 4, right? Type 4 somewhere, right? So F40 means what is the time needed to complete this, provided at 3 we ended here. Similarly, F41 means what is the time needed to complete 4 and up, provided we ended at max of 3. Okay, so that is the definition of F type comma that. Now let's discuss about the recursion. So okay, so we'll find the, we are at t, ft comma flag. Okay, let's do for 0 only, right, as of now. Ft comma 0. So for tth type, we have two choices to go to first, or we have two choices for ending, either at the minimum or at the maximum. So what if we go to the minimum? What will it be? We will recurse to what? If we go to the minimum, we will recurse to what? We will recurse to if t plus 1. We are going to t plus 1 type now, and we have ended at the minimum, so that's why flag will be 0. But we also have to tell the cost, right, or the time needed for completing t level. What is the time needed to complete t level? It is basically, so we have ended at minimum. That means first we went to maximum. We have ended at minimum. We end at here. So we should go to this one. From here we should come here. So it is basically first from, and where were we at? We were at 0. That is minimum of 3. So ABS of minimum of t minus 1 to maximum of t. First move we do is from t minus 1, minimum of t minus 1 to the maximum of t, plus ABS of from maximum of t we come back to the minimum of t, we come back to the minimum of t. So this much amount of time will be taken. Again, for t minus 1, as it was t0, ft0, so this means that for t minus 1 we ended at 0. So at t, we have two choices for ending, either at the minimum or at the maximum. If we end at the minimum, that is, will recurse to f t plus 1 0. Why t plus 1 0 again? Because at t we are ending at the minimum, so that's why 0. What is the amount of distance that we are covering? From minimum of t minus 1, we are going to the maximum of t. And from maximum of t, we are going to the minimum of t to collect all the fruits of type t. So this much amount of time we spend. So this will be the total amount of time. Similarly, we can decide the second part. We can decide to end at the maximum. So we can decide to end. This is the maximum again. This is the minimum. We can decide to end at the maximum. So what we'll do in that case, let's say we were here. We will go to the minimum first. From t minus 1, we'll go to the minimum first. And from here, we'll go to the maximum. So if t plus 1, 1. Why t plus 1, 1? Because for t plus 1, we have to know where it ended for t. For t, it ended at the maximum. So that's why plus 1. Plus, what is the distance that we covered? Distance we covered is ABS of what? Mean of t minus 1 to mean of t. We covered this much distance first, t minus 1 to t, plus ABS of from minimum of t to maximum of t we go. So max of t minus mean of t. And what do we want? We want the minimum amount of time. So we want the minimum out of these two. We want the minimum out of these two. Let's write it more properly, right? Let's write it properly now. Is this clear with everyone how the recursion is getting formed? So if, let me know if it is not clear. If t0 is what? It can be the minimum of if t plus 1 0 plus ABS of what? ABS of max of t minus mean of t minus 1 plus ABS of max of t minus mean of t. Again, why this thing? Because from t minus 1, we are mean of t minus 1, because here we have 0, that is we ended at the mean of t minus 1. From mean of t minus 1, we'll go to max of t, and from max of t, we'll go to mean of t. So this much time will be needed. And why are we going to mean of t? Because we are ending at 0, f of t plus 1, 0. Or f of t plus 1, 1, that is we are ending at the maximum. So first, from mean of t minus 1, we'll go to the mean of t. So mean of t from mean of t minus 1 plus ABS of from mean of t to the max of t. So max of t minus mean of t. The minimum of these two things will be our answer, right? What is the base case? Base case will be, let's say there are t types. So f of t anything flag f of t flag will be what? Basically t types means type from 0 to t minus 1 types. So f of t flag will be what? Flag will determine for type t minus 1 we ended at minimum or maximum. So we have to return back to 0, right? We have to return back to 0. So we have to return this value, that is if it is flag is 0. So base case will be if t0 will be the minimum of t minus 1, ABS of t minus 1, capital T minus 1. Similarly, if t1 means we ended at the maximum, so we have to come back. So ABS of max of t minus 1. ABS of max of t minus 1, right? So that is the base case, and this is the recursion. And what will we start off with? We'll only for the first level we can compute it manually. For f0 we can calculate it manually, right? Yeah, the answer, okay, so the answer will be f0, and yeah, it can be 0 or 1. Okay, actually answer will be what will be the answer? The answer will be, we'll start off at 1 because so we'll compute f of 0 manually. So we'll compute f of 1. The answer will be f of 1 0 plus 1 0 means for 0 we went to the minimum, so plus the distance to go to the minimum, that is abs of min of 0, right? And we want the minimum out of these two, or f of 1 1, that is we went to the maximum, so abs of max of 0. For type t can be considered as our origin, right? Because the actual fruits are from 0 to t minus 1. No, that is here we are doing loop on the types. This has nothing to do with the origin. This has nothing to do with the origin of the line. Types are 0, 1, 2, t minus 1. These are the fruit types. These are the fruit types. What I'm saying is, after completion of t minus 1, that is after we have completed all the types of fruit, we have to go back to the origin, right? So when our recursion comes to f of t comma 0, what does this mean? We have covered all the fruits of type 0 to t minus 1. For t minus 1th fruit, we have ended at the minimum. So we have to, from the minimum, we have to go back to 0. So what is the cost for this? This will be abs of minimum of t minus 1. Similarly, f of t1, what does this mean? For the t minus 1th fruit, we have ended at 1. So we have to go back to 0. What is the cost? abs of max of t minus 1, right? So that will be the cost. So let's try to write the code for this now. I hope this makes sense. Let me know if this doesn't make sense. Cool. Yeah. Okay, let's try to write the code for this. So the first thing we want to compute is the minimum and the maximum for each type. So how many types are there? Vector int types. Okay, that is the that. So num types equals to, okay, so I hope the types are properly there, like 1 2 3 like that. Let's see. Types are 10 to the power 5, and assuming all the type fruits are there, or it might be that ith type is not there. In that case, it will be a bit problematic. So what we'll do is, first of all, map all the types to like 0 to t minus 1, right? So int t equals to 0, and right, int t equals to 0, and set int types, or let's call it vector int all types equals to yeah, vector int all types equals to vector int all types equals to types initially. We'll initialize with this. Now sort all types dot begin, all types dot end, right? Now what we'll do here is all types dot begin, all types dot end. First of all, we're sorting. So what we'll do is we'll basically have them stored. So int mapping. Let's have a constant n here somewhere. Int 25 plus 5. So mapping of size n, and initially 0, everything is 0. So for int, or initially everything is -1, mapping is -1 initially, let's say. For int type belongs to all types, we are looping for all of them. Now if mapping of type is equals to -1, then that means it is not computed yet. So we'll give it a value. So mapping of type equals to t plus plus, similar to coordinate compression, right? But here what we're doing, we are just making sure that there are no blanks in between. Like it might happen that type 1, type 3, type 5 is present, so we are just mapping it to 1 2 3 or 0 1 2, right? So type equals to t plus plus, and that's there. So for all, for type belongs to all type, mapping of type equals to 1, mapping of type equals to t plus plus. That's okay. Now what we'll do is, yeah, we'll do is for all the type, mapping of type, we actually do not want to unmap it anyways, right? So that's fine. This should be fine. So we'll just change our type. So for int I equals to 0, I less than types, size I plus plus, types of I is equals to mapping of types of I, right? Now what we'll do is for each type we'll store the minimum and the maximum. So t, uh, min t of size t, similarly int max t of size t will store initially. So I think mapping n minus 1 does not set all values to, okay. We can then run the loop. That's not an issue. Or we can use fill as well. Fill is there. So fill mapping plus n minus 1, right? So that is also there. So min t, so we have min t here and max t. One second. Yeah. What will be min t? Min t will be the minimum and max t will be the maximum. So for int I equals to 0, I less than uh, yeah, I less than locations dot size, or I less than n, I plus plus, and min t will initialize this with, let's say, int max. Yeah, and max t will initialize this with int min. So min of types of I is equals to min of, not min t. Min t of types of I is the min of whatever value is there, min t of types of I, or the current locations of I. Similarly, max t of types of I equals to the max of max t of types of I, or the location that we are at, locations of I. Okay. Now this will basically do sorry, I'm not sure if fill will also, fill doesn't work for -1. If that's the case, we can just run a loop for int I equals to 0, I less than n, I plus plus, and mapping of I equals to -1. We can always do this, right? So max t and min t is computed. Now what we want to do is we want to do the dp. So in dp t plus 1 and 0, sorry, t plus 1 and 2. So first of all, we'll start with the base case. So the base case will be dp t0. What is dp t0? dp t0 will be the ABS of min t. We have ended at min t, right? That means we have ended at min t. Now we want to come back to 0. So min t of t minus 1, the ABS of that, and dp of t1 is equals to the ABS of max t of t minus 1. So this will be the base case. Now for int I equals to t minus 1, I greater than equal to 0, I minus minus okay, t minus 1, I greater than equal to 0, I minus minus, dpi, let's do it 1 up to 1 and 0 will compute manually, right? Yeah, t greater than equal to 1, I minus minus. So what we'll do here is dpi, again, what did we discuss? And also flag will also be there, right? Sorry, for int, or let's do it manually. So dp I0. dp I0 means we are at the ith type, and for the last I minus 1th type we have entered at the minimum, right? So it will be the minimum of dp I plus 1 0 plus some value here, that is the cost, and also dp I plus 1 1 plus the cost, right? So what is the cost? I plus 1 0 means for I also we have ended at the minimum. So how are we traveling from abs of, from min t of I minus 1 min t of I minus 1, we are going to the max t of I, max t of I, max t of I, and from there plus abs, from there, from max t of I we are coming to min t of I, and we are ending here at min t of I, and that's what 0 points, right? So that's one case. Second case will be it ends at 1, that means it ends at the max t of I. So how did we travel from min t of I minus 1, we go to min t of I, and from there, from min t of I we go to max t of I, right? We go to max t of I and we end there. That's why dpi plus 1 1, or yeah, dpi plus 1 1. So that is the first condition, right? Similarly, we have dpi I1. Let's write it here only. Yeah, that's good. So dpi I1 means for I minus 1 we had ended at 1. So again we'll just copy the same thing will happen here as well. Just from min t minus 1 it will change to max t minus 1. So it will change from here, from this it will change to max t I minus 1 to max ti, and the remaining move. And for the second part as well, from min t, instead of min t it will be max t to min t of I, and from min t of I to this part, right? Okay. So that is the dp. And finally for 0 we will compute dp 0 0 dp 0 0 is what? Okay, so dp 0 0, in fact we can do answer. So either we went to, for 0 we went to the left part, so either the answer will be min of, we went to the left, the minimum of 0, so answer abs of min t of 0, and from there abs of min t of 0 plus dp 1 0, because we ended at minimum for 0, plus dp 1 0, or abs of min t of, sorry, max t of 0 plus dp 1 1, and return answer. So that should be the code. Just one thing, we are assuming that there are at least 2 types available with us. So we have to handle, if there is one type available with us, we have to handle it a bit separately. So sorry. So what we'll do here is, where was t? Yes, if t equals to 1, if t equals to 1, right? So if t equals to 1, rather we'll do it below this. So if t equals to 1, we'll just return minimum of abs of min t 0 or max t0. So that should be the entire code. Let's try to run this and see if this is working. There is a chance it is like it went wrong somewhere. So yeah, compilation error obviously. Int min t. Oh, what have I done? Okay, why have I done like this? Sorry. Min t max t, and for int I equals to 0, I less than t, I plus plus, min t of I equals to int max, max t of I equals to int min. So let's run it now. Compilation error, no matching abs int. Okay, abs int somewhere it came. Sorry, abs, let's see abs of this. Yeah, abs of this, or let me just reduce the screen. So abs of this plus abs of this part abs of this okay. 46, line 46. Oh, here. So abs of min t0 or abs of max t0. That should be it. So let's try to compile and run. Yes. So okay, we are getting 10 and 18 for some reason. Let's try to do a dry run on this maybe and figure it out. Okay. So we have 1 2 3 1. Okay, 1 2 3 1. The standard case only is filling. So here we have three types, right? 1 2 3 1. We have three types. So what are we doing? First of all, let's do a cout. Where will we do a cout? Okay, let's come here. So first of all, we'll do a couple of couts here. So minty max, that's fine. T equals to 1. So let's do a cout t endl number of let's see if this is giving correctly. 0 1 2 for int I equals to 0 and also for int I equals to 0, I less than t, I plus plus, cout min t I and max t I, and after that let's give a endl, right? So let's see what is the output for this. Where when there is only one type, then the answer is pan for min to max, right? Oh yes, my bad. Yes, sorry. Yes, it will go from the minimum to maximum. In fact, this one also I think I have done wrong. Okay, my bad. Yes, this one also, this condition is also wrong. You're right. So it will be either min t from 0 to min t. So what it will be? It will be 0 to min t plus abs of min t to max t plus abs of max t0. Like either we are going this way. In fact, that will be the same thing, right? Or no, that will actually be a bit different. Or it will be abs of max t plus this part will be same, min t to max t. This part will be same. abs of min t to max t plus abs of, in fact both of them are same because we are coming back to Yeah, so it will just be one time we have to write. We don't have to write a minimum because we are coming back again to 0, right? So anyways it will be computed. So ABS of min T0 plus ABS of max T0 plus ABS of min T0 minus max T0, right? And here also for 0 we have just taken we are just going to like one of the minimum or maximum, but we have to collect the fruits as well, right? So this is where we end. So we should begin at the other way around. So ABS of, yeah, so ABS of min max T0 plus ABS of max T0 minus min T0, and we come to the min T and from there we start, or otherwise ABS of min T0, we come to the minimum and from minimum we go to the maximum. So ABS of max T0 minus min T0, max T0 minus min T0, T0. So that should be there. Let's compile and run this now. Okay, we have 18 and this is also correct. So let's remove the C outs, right? Where did we do C out and C out? Let's comment these out. Okay, so how do we estimate time complexity again? Generally the time running time, like when you have 10 to the power 5, you have the flexibility up to n square root of n, right? So generally you have to keep it within 10 to the power 7 to 10 to the power 8 limit. So n square root of n will work, but if it is 10 to the power 6, then at max you can go up to is n log n. If it is 10 to the power 7, then generally it should be order of n or something like that. So let's try to submit this now. Okay, it is exceeding the time limit. Why is it exceeding the time limit? So 1 5 plus 5 all types mapping, and we are also using integer array here. Not sure why is it exceeding. So I equals to 0, I less than n, I plus plus, mapping of I equals to -1. Got it. In fact, all types and all type of n minus 1 we could have taken here, right? Instead of n, we can take it as all types of n minus 1, the last value, like the major value that we have. So plus 1. Mapping, and this is there. So min t and max t we are computing, and dp t0 for t we are doing this, and abs of this. Okay, that should be fine. Maybe we can do a bit of optimization, like we are computing min t I to max ti every time. So let's, maybe we can maintain that in a difference, right? So something like a difference of I, a bit of computations, but again, like that should have ideally worked. Let's see if this works. uh, we were creating 10 to the power 5, so that might be possible for that reason. Okay, actually mapping I less than n, mapping of type. Okay, why have, so type cannot be, oh, we need a long answer. Yes, we need the answer in long, so we have done in integer. uh, we have to have a long answer, and dp is this, and min t max t also, let's keep it long, so that all the calculations are happening in long only. So long, and when we are doing min t locations of I into one long into one long, right, in long. So that will be there, and max t min t dp1 dp is also in long, so that should be fine. So let's try to submit this now. Yeah, we need long. It was given, I missed that. Minty of types of I. Let me see what happened exactly here. So Minty of types of I is in long, comma, locations of I into 1L. Why is that a problem? Minty is in long right now, right? So what is the problem here? No matching for, okay, it is in long. So let's do it in long, LL, 1 LL and 1 LL. Now does this run? Line 65. 65 should also, yes, 65 should also be using long. So long answer. And any other place we are missing? Let's see if this works. Yeah, so this works. This is the final code. Yeah, again, like this is the code has become a bit longer, but again you get the idea, right? Like it's nothing, we are just going from one type to another type, and what we are doing is we are identifying where do we end for the previous type, so that, and for the next type also, for the current type as well, where do we end, right? That will be like handled. So how are we handling that? Like this 0 or 1 will determine where do we end in the current place, and this 0 or 1 will determine where do we end in the previous type. And basically if we end at the minimum in the previous type and the maximum in the current type, so how can we go from there? So from minimum we can go to the minimum, and from minimum we can go to the maximum, right? So that's the way. Similarly, if we end at the minimum here in the previous type, and in the current type we also end at the minimum, so how can we go from minimum will go to maximum, from maximum will go to minimum? That's the way. So it's just writing the conditions, but otherwise it's nothing else. One thing to note here is often if you see, there is no importance of this end, right? In the DP state there is no importance of this end, so it's not, in most of the cases generally we use the array length as one of the states, the current length left, but it is not true that it will always be the case. So you have to understand with the problem that what will be the state. Here there was no need of this state, because we just wanted to go from one index, one type to another type. So the state was more important here, right? Similarly, we just so we rearranged our problem. We rearranged the entire problem from containing the locations to a type based problem, right? So where n becomes the type, right? So for each type we store the minimum and the maximum, and we model the problem like that. So again, like this type of problem is also possible, where the states might not be very clear, but again once you understand the problem and what you need to do, you can easily come out with the recurrence, right? So that's about today. We have already been almost 2 hours here, right? So thank you guys for joining in, and I'll be seeing you next Saturday. So make sure to write the code for each of the problems at least once, right? Because again, like the problems were very good, and if you see, this DP was also very good problem. So definitely try to write the code yourself, and it will like definitely help you in the longer run. So thank you, and I'll be seeing you guys next Sunday. Bye.